Hello dear children, and I'm sure you all are finding this chapter number 3, pair of linear equations in two variables, very easy to solve. And I told you that this is one of the scoring chapters in our textbook as far as our examination is concerned. We have completed the chapter up to exercise 3.5, and today we are going to start with exercise 3.6, and this is the first sum. Solve the following pairs of equations by reducing them to pair of linear equations. Look at the sum given to you, children. The major difference is in this sum, the variables are at the denominator. And up till now, up to all 5 exercises, what we have seen is that the variable is never at the denominator. We used to get some constant terms at the denominator, but never the variables. So now in such cases, how to go ahead, how to convert this into a proper systematic standard form of pair of linear equations in two variables. Let us understand that. So what we'll do, we'll consider equation 1 as 1 upon 2x plus 1 upon 3y is equal to 2, and 1 upon 3x plus 1 upon 2y is equal to 13 upon 6 as equation 2. Now to convert this into a proper standard format, in this case, we will consider let 1 upon x is equal to u and 1 upon y is equal to v. We can take any variable. I have chosen u and v. So let's move ahead and check out how we'll solve it. As I said, these are our two equations. Now children, equation 1 I can write in this form. Please be careful, just look at this. This is very important step. So I have written the equation in this manner. 1 upon 2x, you can write 1 upon 2 into 1 upon x, plus 1 upon 3y, we can write 1 upon 3 into 1 upon y, and is equal to 2 as it is. Alright. Now children, we have considered 1 upon x as u. So I'll write 1 upon 2 into, in place of 1 upon x, I'll write u, plus 1 upon 3 into, in place of 1 upon y, we will write v. Understood? Because we have taken the substitution in that manner. 1 upon x as u and 1 upon y as v, and this is equal to 2. Now you all are aware how to solve this because we have the constant terms at the denominator. So let us cross multiply and simplify this. So we will have 3u plus 2v upon 2 into 3 is equal to 2. Again solve it. So 3u plus 2v is equal to 12. Alright. So let's see now how we'll write equation number 2. We'll write 1 upon 3 into 1 upon x plus 1 upon 2 into 1 upon y is equal to 13 upon 6. And we have taken the substitution as 1 upon x is equal to u and 1 upon y is equal to v. And as I said children, this is the most important step of our sum. What you are substituting in place of 1 upon x and 1 upon y, you should be very careful when you substitute that. So this equation will become 1 by 3u plus 1 upon 2v is equal to 13 upon 6. So we have taken 1 upon x as u and 1 upon y as v. So now we get 2u plus 3v upon 6 is equal to 13 upon 6. We have cross multiplied and solving it. So you get the equation as 2u plus 3v is equal to 13, and we will call this as our equation 4. So children, you can just see equation 1 and 2 where the variable was at the denominator. We have simplified it and we have converted equation 1 into equation 3 and equation 2 into equation 4. And if you look at equation 3 and 4, they are in proper standard form of pair of linear equations in two variables. Now solving this is very easy. Now it's your choice. Either you can solve it by substitution method or elimination method, whatever you feel is easy for you. Okay, so these are two equations. Now let's see how to solve it. From equation 3, we will write 3u is equal to 12 minus 2v. That is 12 minus 2v upon 3. Now we will put this value of u in equation 4, and our equation 4 is 2u plus 3v is equal to 13. Let's substitute the value of u into this equation. So 2 in the bracket, let's take this value of u, that is 12 minus 2v upon 3 plus 3v is equal to 13. Now if you observe this equation, we cannot cancel anything, but we do not want anything at the denominator. So what will we do? We will multiply throughout by 3. So that will give us 3 into 2 into 12 minus 2v upon 3 plus 3 into 3v, and that is equal to 3 into 13. So this denominator 3 and this 3 we can cancel, and therefore we are left with 2 in the bracket 12 minus 2v plus 9v is equal to 39. And let's solve this. So 24 minus 4v plus 9v is equal to 9. Then minus 4v plus 9v is equal to 39 minus 24. And this is now simple solving. So we get 5v is equal to 15, and that will give us the value of v, which is 3. Now let's find out for the value of u. So we'll put v is equal to 3 in equation 3, and our equation 3 is 3u plus 2v is equal to 12, and if we substitute this, we get 3u plus 2 into 3, that is equal to 12. So 3u plus 6 is equal to 12, that will give you 3u is equal to 6, and so we get the value of u as 2. Alright, v and u, both values we have calculated. But this is not the answer. We want to find out values of x and y. So how do we do that? Just check out. We have taken u is equal to 1 upon x. So let's substitute the value of u as 2. So you get 2 is equal to 1 upon x, and therefore x is equal to 1 upon 2. Similarly, we have taken v is equal to 1 upon y. Therefore 3 is equal to 1 upon y. That will give you the value of y as 1 upon 3. And children, this is called as resubstituting the values, which is very important step, and in a hurry while solving the sum you forget this. You end up your sum at v is equal to something and u is equal to something, and then you forget to find the values of x and y. So do not forget this. Resubstituting the values of v and u is an important step, and you're not going to forget this. Alright, so x is equal to 1 by 2 and y is equal to 1 by 3 is the solution of given equation. Alright, so moving to the next sum. This is second sum from exercise 3.6, and the main question is question number 1. Now look at both the sums, and you have the variable at the denominator, and that too into square root sign. Got scared? I know, not at all, because we can make it simple always and solve it. So we'll consider 2 upon root x plus 3 upon root y is equal to 2 as equation 1, and 4 upon root x plus 9 upon root y is equal to minus 1 as equation 2. Now what will be our substitution? Our substitution will be, let 1 upon square root x is equal to u, and 1 upon square root y is equal to v. So how will we write that? It is 2 into u plus 3 into v is equal to 2 is equation 3. And you can make out that our equation number 1, we have made it so simple to solve it. Similarly, we will have 4u minus 9v is equal to minus 1. We will name this equation as number 4, and you can see that we have again made it so simple. This is our equation 2, and equation 2 we have converted into a simple equation which is in the standard form of linear equations in two variables. Alright, now solving these two equations are easy for us. These are two equations which we have made. Now how to solve it? From equation 3 we will write 2u is equal to 2 minus 3v. So that will give us the value of u as 2 minus 3v upon 2. So this value we will put in equation 4, and our equation 4 is 4u minus 9v is equal to minus 1. So 4 in the bracket we will substitute the value of u, which is 2 minus 3v upon 2, minus 9v is equal to minus 1. So here we can cancel this 2 and 2 2s are 4. So what are you left with then? 2 in the bracket 2 minus 3v minus 9v is equal to minus 1. Let us solve this, and we are getting 4 minus 6v minus 9v is equal to minus 1. Still we need to simplify this to get the value of v. So minus 15v is equal to minus 5. We can cancel minus minus from both the sides. So we're left with v is equal to 1 upon 3. Let's find the value of u now. So we can put this value of v in equation 3. This is our equation 3. 2u plus 3v is equal to 2. We'll put the value of v here. So 2u plus 3 into 1 upon 3 is equal to 2. We can cancel this 3. So we are left with 2u plus 1 is equal to 2. So 2u is equal to 2 minus 1. We are getting u is equal to 1 upon 2. Then I told you what is the important step which you should not forget. It is the resubstitution. So we have to find values of x and y. We have taken u is equal to 1 upon x, but we got the value of u as 1 by 2. So 1 by 2 is equal to 1 upon root x. Then what will we do? Root x is equal to 2. We'll take the reverse of both the terms. So square root 2 is equal to, square root x is equal to 2. If we square both the sides, we'll get root x square is equal to 2 square. Root x square is x. So x is equal to 4 is our first value. Similarly, v is equal to 1 upon root y. So we'll be writing it like 1 upon 3 is equal to 1 upon root y. We'll take the reverse of both the terms. So you're getting square root y is equal to 3. Squaring both the sides once again. So we get y is equal to 9, and that is the value of y. Alright. So our final answer is x is equal to 4 and y is equal to 9 is the solution of given equation. So you have seen, children, we have made that square root of the variable in the given sum as a simple equation, and we have solved it. Alright. So moving to the next sum. This is question number 4 from the main question, that is question number 1 of exercise 3.6. Looking at this sum, this looks again very different, but after solving you will feel that even this is also easy to solve. So what we will do, 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2. We'll consider this as the equation 1. And 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. We will consider this as equation 2. Now how to substitute here? Because at the denominator we have not only variable, but we have a constant term along with the variable. So here the substitution will be like this. Let 1 upon x minus 1 is equal to u and 1 upon y minus 2 is equal to v. So in place of 1 upon x minus 1 and 1 upon y minus 2, we will substitute u and v. And so our new equations will be 5u plus v is equal to 2 and 6u minus 3v is equal to 1, and we will number them as 3 and 4. Now these are again our simple equations. You can either solve it by substitution method or by elimination method, that is your choice. Okay, So from equation 3, it's easy for us to substitute for the value of v. So we will write v is equal to 2 minus 5u. And this value we will put in equation number 4 so that we can get the value of u. So 6u minus 3v is equal to 1 is our equation 4. We'll write 6u minus 3 in the bracket 2 minus 5u is equal to 1. That means we have substituted the value of v here in this manner. Let's solve it. 6u minus 6 plus 15u is equal to 1. This we get after simplification. Again we need to simplify. So 6 plus 15u is equal to 1 plus 6. We get 21u is equal to 7. That will give us the value of u as 7 by 21. Reduce it, we get u is equal to 1 upon 3. Alright, so we'll put this value of u in equation 3. This is 5u plus v is equal to 2. This is our equation 3. If we put the value of u here, we'll get the value of v. So 5 into 1 upon 3 plus v is equal to 2. So we get v is equal to 2 minus 5 by 3. Cross multiply. So we get v is equal to 2 into 3 minus 5 upon 3. That will give you v is equal to 6 minus 5 upon 3. And 6 minus 5 upon 3 is 1 by 3. We got the values of v and u. Now what next? Next is very important step. That is putting the values of u and v into what we have taken for that, so that we can get the value of x and y. So we have taken u as 1 upon x minus 1, but we got the value of u as 1 upon 3. So we are writing 1 upon 3 is equal to 1 upon x minus 1. Let's reverse the ratios. So you get x minus 1 is equal to 3. So x is equal to 4 is our first answer. Similarly, we have taken v is equal to 1 upon y minus 2. But we got v as 1 by 3. So that is equal to 1 upon y minus 2. So y minus 2 is equal to 3. So we got the value of y as 5. And this is what is our final answer. So x is equal to 4 and y is equal to 5 is the solution of our equations. Alright children, so this is what is the exercise all about. Question number 1 is reducing the given equations into standard form and then solve it for the values of x and y. So we will continue solving this in the next video lesson. Till then, keep revising and take care.